We're going to talk about how to add and subtract complex numbers. So the way you add complex numbers is what you do when you add polynomials, which you may remember from hearing back in Algebra 1. So remember what you do when you add polynomials is you identify the like terms that are in each expression and then combine them. So for example, if I do 3 plus 5x plus 4 minus 3x, I put the 3 and 4 together because those are constant terms, and I put the 5x and the minus 3x together because those are variable terms. And then when I simplify, I do 3 plus 4, which gives me 7. 5x minus 3x gives me 2x. So when we add complex numbers, we do something very, very similar. You're going to take the real part. So here you do 2 and negative 8, and you combine them to get negative 6. And then you combine the imaginary parts, 5i plus 6i, which gives you 11i. So let's look at some examples. So let's add negative 5 plus 8i plus negative 1 minus 6i. So what I'm going to do here is I'm going to identify the real part. So that's going to be negative 5 and then plus negative 1. And then I'm going to combine that with the imaginary parts. So the imaginary parts are 8i and then minus 6i. Be careful that you're keeping the sign that's in front of the term with it when you rewrite your expressions. So when I combine negative 5 minus 1, because that plus negative becomes a minus, I get negative 6. And then I have plus, and then 8i minus 6i is going to give me 2i. So that will be my final answer, negative 6 plus 2i. So now let's try this example. So here we have two complex numbers that are being added together, but notice that both of these has a coefficient in front. So I'm going to go ahead and start off with my distributive property, just like I would do with a polynomial. And then, so I have 3 times negative 2, so that's negative 6, plus 3 times 3i, so that's 9i. And then plus 2 times 2, which is 4, and then plus 2 times 3i, which is 6i. So now let's go ahead and combine the real part. So let's do negative 6 plus 4. And then let's combine the imaginary parts. So we have 9i plus 6i. So when we combine these, we do negative 6 plus 4, which is negative 2, and then we have plus 9i plus 6i, which is 15i. So negative 2 plus 15i is going to be my final answer. So now you can go ahead and pause the video and try doing this example on your own. So here, when you combine the real parts, you get 5 plus 2, which is 7. And then when you combine the imaginary parts, you do negative 7i plus 4i, so that's going to be minus 3i. So 7 minus 3i is your final answer. So now let's subtract complex numbers. So subtracting complex numbers is very similar to what you do when you subtract polynomials. So remember, what we do is when we have like two polynomials and we have one that's being subtracted, we go ahead and switch it to addition of the opposite. So what I do is I kind of think of this as 6 plus 5x plus negative of 2 minus 3x. And then I just kind of go ahead and distribute that negative to every term in the second polynomial. You can also think of this as just switching this to a plus sign and then switching all the signs here to the opposite, okay? Adding the opposite. So when we do that, then we just follow the rules of addition, right? We combine the like terms, so combine the constants. 6 plus negative 2 is 6 minus 2, so that's 4. 5x and then 3x, we combine the variables, and then that gives us 8x. Okay, so very similar to what we do with complex numbers. So if we have 4 minus 8i minus 3 minus 6i, we're going to rewrite this as 4 minus 8i plus negative 3 plus 6i. Notice I've switched every sign on the second complex number. Then we combine the real parts like we always do, and we get 1. And then we combine the imaginary parts, and we get minus 2i. So now let's try this example. So here we're subtracting two complex numbers. So my very first step is going to be to rewrite this problem as an addition. So I have negative 2 plus 6i, and then I'm going to write plus. I'm going to switch every sign in my second complex number to the opposite. So I have negative 5 plus 3i. Now I'm going to go ahead and do exactly what I did when I was adding. So I do negative 2 minus 5, so that's going to give me negative 7. And then I do plus 6i plus 3i, and then that gives me plus 9i. So this is now my fully simplified answer. So same idea if we have a coefficient. I'm always going to start off by rewriting this as an addition problem. So I'm going to do 5 times 3 minus 3i, and then plus negative 2 times 3 plus I. Okay, so now what I'm going to do is I'm going to go ahead and distribute. So I do 5 distributes here. So I have 5 times 3, so that's 15, and then minus 5i. And then plus, and then my negative is going to just go ahead and distribute along with the 2, and that's going to take care of the switching signs part. So negative 2 times 3 is negative 6, and then negative 2 times I is minus 2i. So now I need to combine the real part, so I have 15 minus 6, And then that's going to give me 9. And then I'm going to combine it with my imaginary part. So I have plus negative 5i and then minus 2i. And so that's going to give me plus negative 7i. Plus negative, I can just go ahead and turn into a subtract. So my final answer is going to be 9 minus 7i. So now let's go ahead and subtract here. So here we're just subtracting two complex numbers. So I'm just going to do as I was doing initially. So I do 4 plus 6i and then switch it to an addition and switch every sign on the second complex number. So now I just go ahead and combine the real part. So I have 4 plus 1, which is 5. And then I combine the imaginary part, 6i minus 2i, so that's plus 4i. So 5 plus 4i is my final answer. So you can add complex numbers by combining the real parts and the imaginary parts. And remember, you can subtract complex numbers by distributing the negative to all the terms in the second number and then adding the numbers together.